Okay, let's unpack this.
Let's do it.
If you are standing on the fence, about buying an electric vehicle,
Mm-hmm.
there is likely one question, or maybe one terrifying dollar amount that just keeps cycling through your mind.
And that is, how long is that huge battery actually going to last?
Exactly.
It's the $40,000 question, sometimes literally.
Right.
And it's a completely rational fear.
It is.
The only lithium-ion batteries most of us really have experience with are the ones in our phones, our laptops.
Yeah, the ones that die after 2 years.
Right. We watch those capacities just drop and drop until the thing is basically tethered to a wall.
So you transfer that fear to a car that costs, what, $50,000?
Yeah.
It's a huge source of anxiety.
Very high value asset. Yeah,
Yeah.
it fuels that core anxiety.
Absolutely. So our mission today is to get past that anxiety and just look at the hard data.
Right.
We're leaning really heavily on an analysis from a startup called Recurrent. They've made it their business to monitor EV battery health with real-world numbers.
Mhm.
So we need to settle this. Are EV batteries just oversized, degrading phone batteries, or is this a solved problem?
Well, the data offers, an immediate and pretty overwhelming reassurance.
Which is,
They are not oversized phone batteries. Not at all. Modern EV batteries are engineered so differently, and they're proving to be extremely reliable.
the failure is rare.
Really rare. The probability of catastrophic failure is very, very low. Liz Najman, she's Recurrent's director of market insight, she put it perfectly. She said replacing a battery outside of a recall is really rare.
That's a strong statement. But let's get into the methodology. For you listening, how do they even know this? Recurrent is pulling data from thousands of vehicles.
Right, in real time, yeah.
So what is this telematics data, and how can they tell a battery was replaced versus just, losing some capacity over time?
Right, good question. So telematics basically means the car is constantly communicating its data mileage, charging habits, internal temps, all of that.
Back to a central system.
Exactly. And to track replacements, they look for these sudden huge spikes in a vehicle's estimated range.
Aha, okay.
So imagine a 2018 car with 80,000 miles. It suddenly jumps from, say, a 200-mile range estimate back up to its original 250 miles. Overnight.
That's the smoking gun.
That is the telltale sign that a brand new battery pack was just installed.
Okay, so they're tracking these hard replacement events. Now, when they filter out the big publicized recalls like the Chevy Bolt or Hyundai Kona, which were known factory defects, what's the number?
What does the data say about normal wear and tear replacements?
Yeah.
The overall number is, frankly, a relief. Across all the models they looked at, less than 4% of users have had to replace their battery.
Less than 4%. That is a great baseline for reliability, but that's about total failure, right?
Mm-hmm.
It doesn't quite address the slower, more common fear, which is just degradation, the slow loss of range over 100,000 miles.
It's a great point, because all lithium batteries degrade. That's just chemistry. And the data does show us that, but it also helps contextualize it. Manufacturers have gotten so good at managing heat that the capacity loss is way slower than people think.
So what are we talking about?
Well, studies on popular cars like the Tesla Model 3 show most of them only lose about 10 to 15% of range over the first, say, 150 to 200,000 miles.
That's really manageable.
It is. And when you look back at that 4% failure rate, the most fascinating part is how dramatically it changes when you slice it by the age of the vehicle.
Okay, here's where it gets really interesting.
It really is.
Because that overall 4% figure, it totally hides a historical truth. Early EV adopters, they faced real struggles, and their stories are why this fear is still around.
Exactly. The data shows this clear generational split. The technology has just evolved incredibly fast.
So let's split it up. Generation 1.
Let's isolate that first generation of mass-market EVs. So roughly models sold between 2011 and 2016.
Okay.
Their replacement rate was significantly higher. It clocked in at 8.5%.
8.5. And the poster child for this, of course, was the early Nissan Leaf.
Precisely. The Leaf is the definitive example of learning the hard way. Early models. They lacked active battery cooling.
No liquid cooling at all.
None. They just relied on passive air cooling, which just wasn't enough, especially in hot climates.
So if you were driving a first-gen Leaf in Phoenix,
You were in trouble. That battery was under constant thermal stress, which just dramatically accelerated degradation and, yes, led directly to those higher failure and replacement rates.
I remember those stories. People in Arizona watching their range just plummet in a couple of years. It was a genuine technical flaw that fueled all the skepticism we still hear.
A very serious flaw. But manufacturers learned very, very quickly.
So let's look at Generation 2.
Okay, Generation 2.
Like-
This covers roughly 2017 to 2021. Think early Tesla Model 3 is the Chevy Bolt.
Right.
As soon as they started integrating effective thermal management systems, that 8.5% replacement rate, it just plummeted.
How far did it fall once they figured out active cooling was, non-negotiable?
It dropped to a replacement rate of just 2%.
Wow. From 8.5 to 2.
Yeah. And that massive, immediate shift proves that the key to EV longevity isn't just the battery chemistry itself, it's the systems managing that chemistry. Temperature control wasn't optional. It was the critical factor.
Which brings us to today. If 8.5% was the painful past and 2% was the transition, what do the newest models look like?
This is the most reassuring data point we have for anyone thinking of buying an EV today.
Okay.
For models sold from 2022 onward, the replacement rate is a minuscule 0.3%.
0.3, so 1/3 of 1%.
Yeah.
That's bordering on negligible for something this complex.
It really is. And recurrence analysis confirms that for these newest cars, the issues that do lead to a replacement, they're almost universally tied to factory defects that show up really early.
Not for mileage.
Not from general capacity loss tied to mileage, which was the old fear. If a modern EV battery fails, it's usually a manufacturing flaw, and that's almost always covered by the warranty.
Which is typically 8 years or 100,000 miles.
Exactly.
So the single biggest leap in reliability from that 8.5% down to 0.3 is all down to one thing: thermal management.
100%.
But let's unpack that term. When we say thermal management, what are we actually talking about?
It's this whole elaborate system. You've got cooling loops, heating elements, sensors, all designed to keep the battery chemistry in its happy place.
So it's not just cooling.
No, it's heating too. Unlike the early Leaf that just used air, modern EVs use active liquid cooling. They run coolant through channels inside the battery pack.
Mm-hmm.
And this system can heat the battery in cold weather to help with charging speed and cool it during hard driving or fast charging.
And we see this in action with that preconditioning feature, right?
Exactly. Preconditioning is a perfect example. When you put a charging station into your navigation, the car automatically starts warming or cooling the battery before you even plug in
To get it ready.
to get it to the optimal temperature to accept that high-speed charge, which protects the cells from stress and makes it more efficient.
Okay, so that's the tech side. The engineering it's largely foolproof now, which leads to the next question. If the tech is that solid, are we just wasting our time thinking about maintenance? Or are there still things you can do as an owner to protect that battery?
This is where we shift from what the engineers are doing to what you can do at home,
Right.
because the chemistry is still inherently sensitive to heat and voltage stress.
Right.
So good habits they're paramount to protecting your investment.
We know the sweet spot is between 20 and 30 degrees Celsius. So let's talk about the parts that suffer when you go outside that range. You said it's not just the battery pack.
That's right. The battery cells are the most delicate part, for sure. But the thermal system is also working hard to protect the electronics that manage all that power.
Like the inverter?
The inverter, the OBC, and the DC converter.
Okay, wait. Before we move on, for listeners who don't know the engineering, can we just clarify what the onboard charging unit, the OBC, what does it actually do?
Good call. The OBC is essentially the brain that manages the electricity coming from your home charger.
Okay.
It takes the AC power from the wall and converts it into DC power that the battery can store.
And that conversion makes heat.
A significant amount of heat.
Yeah.
And if the OBC gets too hot, its efficiency drops. And that long-term thermal stress can shorten its life. That's an expensive repair, even if your main battery is fine.
So protecting the OBC, the inverter that powers the motor, and that DC-DC converter for accessories, it's just as important as protecting the battery itself.
We all hate high temperatures. So for you, the owner, the simplest fix is environmental. Park in the shade in the summer.
Use the garage in the winter.
Exactly. Use the garage to shield it from deep frost. These simple things minimize how hard the car systems have to work just to stay stable.
Okay, so with heat management as the main goal, let's talk driving and charging. You mentioned a really critical tip that sounds kind of counterintuitive, the post-drive pause.
This is one of the most underappreciated tips for long-term health.
So what is it?
If you've just finished a long drive, a high-speed highway run, or a tough drive through the mountains, anytime the motor was working hard, It's highly advisable not to shut the car off immediately.
But why? Isn't turning it off the efficient thing to do?
You're keeping the automatic thermal management systems running for a few extra seconds, maybe a couple minutes.
I see.
When the car is under load, everything's heating up. If you shut it off instantly, you interrupt the cooling cycle that's designed to bring those temperatures down gently.
So leaving it in park lets the fans and pumps finish their job.
Exactly. It cools everything down uniformly and reduces what's called heat soak or thermal stress.
And how long are we talking? Do you have to sit there for 20 minutes?
No, not at all. Usually a few seconds to maybe 2 or 3 minutes is plenty. You're just giving the car time to finish its automated process. It's a zero-cost way to protect the whole system.
That is a practical, powerful tip. Okay, let's switch to charging. We know DC fast charging generates a lot of heat, which is stressful. Should we just avoid it completely?
It is stressful, but it's there to be used when you need it. The key is balance.
So don't use it every day.
Right. Don't use it as your daily primary method if you want maximum longevity. But here's the more surprising warning.
Go on.
Be cautious about prolonged, ultra-low power charging.
That seems backwards. I thought slow charging was the gentlest way to treat the battery.
And generally, it is gentler on the battery cells.
Mm-hmm.
But think about the electronics, specifically that OBC, which is doing all the conversion work.
Okay.
If you charge at a very low current, say under 16 amps, for a really extended period like 24 hours straight, you're forcing the OBC to run under stress for a marathon.
It's the duration of the stress, not the intensity.
Exactly. It's the duration of the stress on the hardware that can accelerate wear, especially if it's hot outside.
So the sweet spot is a moderate level 2 charge that gets it done efficiently. Avoid the extremes.
That's the best practice.
Yeah.
And that brings us to the core chemistry of preservation.
Charge levels and cycles. The dreaded 100% rule.
Mm-hmm.
We're all trained by our phones to charge to 100% every night. Does that same warning apply here?
It absolutely does. The chemistry of the cells is happiest when it's operating in the middle of the charge window.
So keeping it pegged at 100% is bad.
Especially for long periods. Like leaving it fully charged for a week while you're on vacation, that accelerates chemical degradation. And letting it drain down to zero all the time is just as stressful.
So for daily driving, the rule of thumb is aim for the middle. Maybe charge to 80 or 90%.
That's the consensus. Maintain a healthy operational window. And remember that warning about leaving the car idle? If you park your EV for a long time, ideally you want to leave it at a moderate state of charge, maybe 50 or 60%. Leaving it idle for months, fully charged or fully dead, is the perfect recipe for cell deterioration.
So gentle, regular use is best.
Within that controlled charge window, yes.
So let's bring it all together. What does this all mean for the person trying to decide if they should buy an EV?
Well, the initial high-cost fear, it's largely obsolete. It's driven by that outdated 2011 to 2016 tech that just couldn't handle the heat.
The data is undeniable.
It is. The modern EV, especially from 2022 on, with that 0.3% replacement rate, has proven to be highly durable. And this reliability comes almost entirely from advanced thermal management.
And for you as an owner, your durability is maximized by managing two things: heat and the charge window.
That's it. Drive smoothly, use that post-drive pause, park smart, and avoid those extreme 100% habits.
It's an incredible technological success story, really, moving from an 8.5% failure rate to near zero in about a decade.
It is, and it raises a fascinating question for the future.
Which is?
Considering how fast this is all improving, both the thermal management and the battery chemistry, what will the 2030 replacement rate even look like? Will longevity get to a point where the battery warranty just covers the entire life of the car?
And battery anxiety just ceases to be a consumer concern entirely.
That's something for you to mull over as the technology keeps evolving.
That is a profound thought. We hope we've managed to explain the data and the tech with some simplicity and clarity today. It's clear our sources offered some really concrete advice and powerful numbers.
They really demystified the whole topic.
They really did.
And thank you for sharing your sources with us and letting us take this deep dive with you. We hope this information helps you feel well-informed and confident.
We encourage you to hit that follow button so you don't miss our next deep dive into the topics that matter to you.
We'll see you next time.